A particle of unit mass undergoes one-dimensional motion. Velocity is equal to, see, it's actually v of x is equal to beta x the whole to the power minus 2n. Where beta and n are constants, the acceleration of the particle as a function of x. So let us start the question by writing down what is given. So what is given is v of x is equal to beta x the whole to the power minus 2n. Now, differentiating both sides with respect to t. So what we get is dv of x by dt is equal to d by dt of b. Okay, that doesn't make sense. Okay, all right. So what we'll do here is we will differentiate this equation with respect to x first. Let's see. So we have d by dx of v, or to be more precise, v of x is equal to d by dx of beta x the whole to the power minus 2n. Now, d by vx of dx is equal to d by dx of beta x the whole to the power minus 2n will be equal to minus 2n into beta x whole to the power minus 2n minus 1. Why? It's simple. So it goes like this. D by dx of x to the power n is n into x to the power n minus 1. So instead of n, we have here minus 2n. Instead of x, we have beta x whole raised to minus 2n minus 1. Now, what we need to keep in mind is that we've been asked to find out the acceleration, and we don't have, this is not equal to acceleration. Why? Because acceleration is equal to dv by dt and not dv by dx. Then what is the method to approach to find out acceleration? See, acceleration is nothing but d by dt of v, which I'll write it as dv by dt like this, and then I'll multiply dx like this, right? So what do we get? dv by dx into dx by dt. Is dv by dx familiar? Yes, because we just found it out. dv by dx to be minus 2n beta x the whole to the power minus 2n minus 1. Let me take you to the process again. What is acceleration? A is equal to d by dt of v, which is dv by dt. And how did I rearrange dv by dt? I wrote dv first here, dt here, then I multiplied it with dx and dx. So dx by dx into dx is 1, so it remains the same. Now, dv by dx, we already have found out dv by dx here. So this is dv by dx, right? So this is the value of dv by dx. But what is interesting is to know that what is dx by dt? So dx by dt is nothing but velocity. So this becomes minus 2n into beta x whole to the power minus 2x minus 1 into what is velocity? Velocity is v of x as given in the question, which is beta x whole to the power minus 2n. So acceleration A is equal to minus 2n into, if you consider this as A and if you consider this as A again, so what we have here is a raised to m into a raised to n, which is nothing but a raised to m plus n. So what we have here is minus 2n into beta x the whole raised to minus 2n minus 1 plus minus 2n. And what is that is equal to? So acceleration is equal to minus 2n into beta x the whole to the power minus 2n is minus 4n minus 1, which is the answer we require. So minus 2n beta x minus 4n minus 1, which is minus 4n minus 1, option A. See, the question appears, it appears really simple, but if you forget this step, or maybe if you just try it as I did earlier, if you try to solve this question using d by dt, it may consume some time to realize that it is not the way that you should do it. So how does that correction comes to you? It comes to you naturally. Okay, so it comes through practice basically. So that's how we solve this question. Let us now move on to the next question.